Hi everyone, welcome to today's webinar. We're happy that you'll join us today for machine-to-machine communication with IoT Edge and HiveMQ. I'm Verena and I'm happy to present you today's speaker Christoph Schäbel, who is a core developer of HiveMQ, and we are also joined by an external guest speaker. So we're looking forward to have Krasimir Galik. Krasimir is an IoT expert working with customers in the workspace of Microsoft Azure. We will start in a minute, but before I want to let you know that you can ask questions during the webinar by clicking on the Q&A tab. Questions will be answered afterwards during the Q&A session by Christoph and Krasimir, and if there's not enough time to answer all questions, we will answer them on the HiveMQ community forum. Additionally, we will also start a quick poll during the Q&A session, and we would be pleased if you could give feedback on this webinar. So I think that's it from my side, and now we're ready to go, and I will hand over to you, Christoph and Krasimir.
Okay. Yeah, we're talking today about machine-to-machine communication with IoT Edge and HiveMQ. And sorry. I work for HiveMQ. Actually, I'm one of the co-founders of HiveMQ, and I've been working with MQTT for some years now. I'm also one of the core developers on our products, especially the MQTT broker HiveMQ. And I do have a background in distributed systems and a little bit in robotics.
So hello everyone. First of all, I would like to thank HiveMQ for inviting me to be the guest today. So my name is Krasimir. I'm an independent contractor with full focus on IoT, mostly dealing with Microsoft Azure IoT services. I've around about 9 years of experience in general in software engineering, and in the last 4 years I have the full focus on IoT, and occasionally I'm also happy to share some of my learnings to my technical blogs and to the occasions similar to this one today. Okay, so what we are going to talk about today. The topic of today's webinar is actually machine-to-machine communication with Azure IoT Edge and HiveMQ. But actually, before we drill down and before we go deeper into this topic, I think it's very essential first to understand some of the basics concept. Like, for example, what is IoT Edge? So what we consider to be Edge, or what is the Edge device? And as well, actually, how does Azure response on these challenges that actually IoT Edge has, and in general that IoT is kind of gives us as a challenge to have. So actually, how does Azure respond with its services and offerings to actually resolve some of the problems that IoT has over there? So yeah, we will talk today about why it's important actually to first shift to the edge, and as well actually how to have cloud managed deployments and how to orchestrate some of the workloads that are actually running near the factory or near the shop floor or somewhere more closer to the devices and machines. And of course, we will reflect as well how, or actually we will talk about one concrete example of that by actually providing or explaining how one of the demos that we did together, how does it work in a sense, how to enable machine-to-machine communication by using and deploying HiveMQ to Azure IoT Edge. So we can go to the next slide, I guess. Yes, so what we call Edge. So I would say that in general, Edge, or if we want to kind of go a little bit to have a little bit broader term, what is the Edge device? So Edge device actually can be a piece of software with some kind of software layer on the top that actually controls the data flow at the boundary between two networks. So this means actually that a device like this, actually it's not located or it's not part of the cloud, it's somewhere placed closer to the devices and machines itself. So idea is actually that these devices are managed by cloud, but on the other side that they are as well kind of close to the machines, because in IoT it's very important that these machines can kind of operate in the offline mode for the extended period of time. So idea is actually that the devices spend less time communicating with cloud in order to be able to react more quickly to local changes, and to operate in a reliable way if we are talking about concrete kind of offline periods that usually in the shop floor devices and machines actually face with. Very often we will hear today a term called orchestrated from cloud, and actually when we say orchestrated from cloud, we actually mean by deployment, configuration, all kind of different updates that occur, where actually idea of this, when we say cloud managed, idea is actually that we eliminate the necessity to actually send someone or send the person to actually operate these devices manually on the shop floor and actually to manually operate these machines. So this is actually very important in IoT because it saves time, it saves costs and resources, and actually enables that everything is done and orchestrated remotely. Next one. So yeah, this is actually the reason why. So like I said before, very often we have a requirement that the devices needs to operate in the offline mode, but they also have to be able to react on the local changes. So in the opposite to that, we have kind of the cloud-based approach, which is actually idea of the cloud workloads is that they have ability to be globally available, and they also have unlimited computing resources. So for IoT, actually, this is sometimes not sufficient. So therefore, it's required to shift some of the workloads closer to the devices, so that devices can actually operate and work first, as I've said, in the offline mode, but also sometimes these devices have some kind of the latency requirements where we can actually not rely, very often we cannot rely on the public infrastructure. So we actually cannot kind of rely that some of the reactions that needs to happen from one machine to another machine, that this actually is dependent on the public network or on the internet. So therefore, we actually have to shift these workloads all the way from the cloud to edge. So actually, so the idea of this or the requirement for the edge in this case would be that actually can run workloads that are specified from the cloud. And actually, what are these workloads? These workloads could be custom logic for data processing, could be some machine learning models for evaluation, prediction, could be some kind of the modules that are doing data pre-processing before the data actually reach the cloud. The reasons for this could be various. For example, like to save the costs in the cloud to send only relevant data. And this is another reason why this is important actually to have it rather on the edge than in the cloud. So at the end of the day, of course, it can also come down to the cost saving. These days, we hear a lot of terms on the internet we can find about intelligent edge or edge-enabled devices and similar terms. And actually, this is exactly what this is about. Their idea is that some of the cloud capabilities are shifted to the edge, whether this is just the custom logic as I've explained, or whether these are some machine learning models that are trained in the cloud, but actually deployed to the edge in order to perform certain assessments and to make to enable the devices and machines to make the decisions without cloud. Okay, next one. So what and how does the Azure answers on these challenges? So actually Azure offers something what we call Azure IoT Edge, and actually our Azure IoT Edge is fully managed service built on Azure IoT Hub. Now, what is Azure IoT Hub? Azure IoT Hub in Azure Vault is the central point, is the cloud gateway that actually enables bidirectional communication and device management at scale. When we are talking about communication between devices in the cloud, in the Azure ecosystem, IoT Hub is actually something that we can almost not avoid. So this is the kind of the crucial point, and actually Azure IoT Edge is just the service that is built on the top, or that is the part of Azure IoT Hub. Azure IoT Edge actually provides containerized environment that is cross-platform, which means that it can run on Windows and Linux. And of course, an idea is that workloads that are about to be deployed to the edge can be tested in the cloud or to be part of continuous integration or continuous deployment pipelines. So this is actually how we achieve the cross operability between the cloud and the edge. So which kind of gives us an opportunity to test it locally, to test it maybe in the cloud. And once we are ready, we can kind of just put it and push it through our pipelines all the way to the device. So essentially the idea of this is once we move these certain workloads from the edge, from the cloud to the edge, or we say edge of the network, finally we actually achieve that our devices spends less time communicating with the cloud, and of course that they can react on some of the changes quickly, and that can actually provide some insights to machine, or maybe, I don't know, shut down some of the machines in case that we detect some failures, and potentially these failures and anomalies could be actually trained in the cloud by training the certain machine learning model and actually deploying it to the edge. So this is the idea, and this is actually what Azure IoT Edge supports. Next one.
Okay, so as this webinar is about HiveMQ and IoT Edge, I just wanted to start off with a little refresher on MQTT and why MQTT makes sense to use on the edge. I'm going to keep it quite short for those who don't know MQTT yet. MQTT is a lightweight, very lightweight protocol that works on top of TCP/IP, and it was built to monitor oil pipelines, therefore it had to be very resource effective, because oil pipelines were monitored by satellite, and traffic over satellite is very expensive. So MQTT is very lightweight because of that. It implements a simple publish and subscribe pattern. As you can see on the right, it's pretty simple. There can be subscribers that are interested in topics. It's organized in a topic structure. And if a message is published to one of those topics that a client is subscribed to, the subscriber gets a message. This has one huge advantage because of publish and subscribe. Sender and receiver are decoupled, meaning that the subscriber doesn't have to know the publisher, and the publisher doesn't have to know the subscriber. All they need to know is the central component, the MQTT broker, in this case, HiveMQ. Yeah, and since MQTT is based on TCP/IP, we do have instant message delivery, because it's not like with HTTP, when you have to poll for new messages, or with Kafka where you have to check if something is in a queue. MQTT actually pushes the message to its subscribers. And it also provides queuing or offline queuing in cases when subscribers are currently not connected. And one big thing about MQTT, it's an open standard. And I'm just going to tell you or show you some about the history of the protocol. The latest version is actually quite fresh. It's from 2019, just from last year. But it was invented for a protocol in the internet quite a long time ago. It was invented in 1999 and took some time to become royalty free up until 2010. And from there on, it always is involved, and HiveMQ involved or evolved with it. Yeah, up to the current version that is MQTT 5. Yeah, quite fresh also is that there is now a HiveMQ open source version and a client that you can use that also fully supports MQTT 5. So why am I talking about MQTT 5 a lot? Because MQTT 5 actually comes with a few new features that are targeted at especially at large-scale deployments or industrial IoT deployments, and all around just make the protocol a little bit better and make it a little bit easier to use. It was always a very simple protocol. You can probably read the specification in 2 or 3 hours and will actually understand it. Something that's quite rare actually for internet protocols in my eyes. So what does MQTT 5 bring on top of previous MQTT versions? It actually does a lot for compatibility and portability, meaning that some features are now optional and clients and brokers can exchange what features that they support. So in previous versions, both had to support more or less all features because they weren't optional. Now they are, which makes it easier to implement very lightweight clients, which is especially important if you're going for more embedded applications. Yeah, then there's also a session and message expiry. Pretty simple, messages and sessions can expire and the client can specify when. There's also a big feature called shared subscriptions. Shared subscriptions is a variant of load balancing for clients. That means multiple clients can share the same subscription. And if a lot of messages are coming on one topic and you want to process that, usually that is done with backend systems. Those can share the same subscription and the messages get distributed to those clients. And they get distributed evenly to those clients. So not every client has to handle every message, but you can have multiple clients that share the load on these topics. And also one new feature are user properties that allows you to add custom or user-defined metadata to messages, kind of like headers with HTTP. Which usually allows you to keep your payloads a little bit simpler than it has been before, or to organize the information on your packages a little bit more. And also the feedback from server to client and vice versa has been improved, which makes it a lot easier for developers to work with the protocol. Because there are more reason codes and more descriptive ones than there have been before. And it is now allowed optionally to add a string where you can have a custom reason or a custom string just to tell what's going wrong or what's going right. And negative acknowledgements were also a part. The broker is now also, or the client, even the client, are now able to tell each other that they are currently overloaded or that they're currently not able to handle a message, so the other side can retry later. And there is a request response pattern that has been added, which allows for additional layers on top of the protocol, like having business acknowledgement. Okay. Okay. Then a little bit about the ecosystem that we offer at HiveMQ. All in all, HiveMQ is an enterprise MQTT platform, and it comes in different flavors. There are commercial ones called Professional and Enterprise that have special features important for enterprise deployments, and for those versions we offer up to 24/7 support. So if you're thinking about going into production or doing larger deployments, this is usually the way you want to go. But there's also the open source community edition, which is the core functionality of HiveMQ. It's a fully featured MQTT 5 broker. And it is also the base for our commercial editions. Yeah, and we also offer not only brokers, but we do offer MQTT clients as well. Currently, there's the Java MQTT client, which is a very high performance MQTT client, which can be used blocking asynchronously, and even comes with a reactive API. It's very easy to start with, and it's very easy to build very performant applications with it. We also do offer enterprise integrations, we call them. HiveMQ comes with an extension framework, so it can be extended. Even with custom extensions, there's an open source SDK if you ever want to implement some custom logic there. And we do offer some pre-built integrations, especially for security, or if you want to integrate Kafka, and there are some more. Yep, so why would I use HiveMQ on the edge? Some of you might have used HiveMQ. I think most of you would have used HiveMQ in the cloud only. But it does make sense to use HiveMQ on the edge. Because as MQTT is an open standard, it brings you a lot of options, especially when it comes to interoperability. When you have devices from different vendors or machines from different vendors, more and more vendors are offering MQTT support already, and it makes it way easier just to talk about the projects if there's a standard that everybody conforms to. HiveMQ supports 100% of the MQTT 5 specification, and in this case, Azure also supports MQTT, but they only support parts of the MQTT 3.1.1 version. If you use HiveMQ on the edge, together with IoT Edge, you have the options to get independent edges. If you think of an edge like, let's say, a factory floor, that allows your parts on the factory floor to communicate still, even if no internet connection is there. You can have your own little network there, and you still can have full MQTT communication between all the machines. And HiveMQ has also some neat features that allow you to control how and what data is going through HiveMQ, or then if we talk about IoT Edge, what data is going to the cloud and what is staying on the edge, which can help you a lot with reducing bandwidth, and therefore also help you a lot with reducing costs. Okay, so if I combine those two, HiveMQ and IoT Edge, why would I combine them? Pretty simple. What the combination gives you is a way to compute on the edge, and also a way to communicate on the edge. one IoT Edge, the other one HiveMQ. And it also gives you a way to let your machines on the same space, on the same edge, talk to each other, bidirectional. And what IoT Edge brings to the mix is that it's very easy to deploy to the edge and even maintain through the edge. You can change the configuration. I think Krasimir will talk about that later on. And it's very simple. What it also brings is you can, while still talking a usual standard MQTT, you have the option to make your edges more intelligent. So you can have custom workloads there. You can do your machine learning right on the edge, and you can use the MQTT data and pass the results from these analyzed data back into the MQTT stream. So you can do all the work, or most of the work, right on the edge, and only push interesting results back to the cloud or to other machines and so on. And it also gives you another option. If you have HiveMQ on the edge, you get a very high throughput MQTT option right at the edge, which is most times very important if you go for industrial IoT cases that require a lot of message rates right at the edge due to very high rates of sensor data going through it. So I've talked a little bit about real use cases, and I just wanted to show you the real use cases we see here. And the first example is simply a machine. I chose a car here because everybody knows what a car is. And if you talk about intra-machine communication, I see the car as one big machine. And the car is effectively one Azure IoT Edge device. But the car comes with a lot of components. Be it an engine control unit, be it sensors on brakes, and so on. And we want to enable these components of the car to talk to each other and also to analyze these data sets and be able to push them to the cloud. That's what we can do with the combination of HiveMQ and IoT Edge. And as told before, it's very easy to manage and operate. And also MQTT is usually has low overhead and brings very low latencies. So it works well in sensor networks or control networks, like for example in machines. Yeah, and as already said, it's a way to be very cost effective because if you have mobile machines like a car, for example, that have to push all the data through mobile networks, bandwidth is something that actually costs money, and the lower bandwidth you need, the more money you save. And there is another use case, we call it inter-machine communication. I think I already started talking about it a little bit. It's if you can example a factory floor with a lot of machines in there, you would see each building or each factory, if you have remote ones, for example, as one IoT Edge device or as multiple. And you could install HiveMQ there, which gives you the option to let your machines talk to each other. It's pretty much the same basic idea as the car, but on a little grander scale. Here, and gives you a few advantages, especially it gives you the advantage that your factory stays reliable. It's completely independent of any internet connectivity, and it's still, even if you don't have any internet connectivity, your machines on that shop floor can still talk to each other, and they can still do it with an open standard protocol. Yeah, it also is very fast. It's interoperable. We talked about this, and it also gives you the option to have your own security measures or layers independent of the ones that Azure or the cloud gives you. You can have your own security rules for the machines on the factory floor, and you can have then your own security rules for the data just going to the cloud or being processed by Azure IoT. Yeah, and pushing workloads down to the factory is a thing that's already happening, because the faster you can have results or analysis from your data on the factory floor, the better.
Yeah, so kind of to combine these two stories together, we will just kind of cover a couple of more IoT Edge concepts in order to understand the terminology at the first place here. So Christoph, can you please move on to the next slide? Yeah, so what is the concept of Azure IoT Edge runtime? So very often when we read the Azure IoT Edge documentation, we will hear Azure IoT Edge runtime. And actually, Azure IoT Edge runtime is nothing else but the two Docker compatible containers that are running on the device itself, that are in charge for communication with the cloud, bidirectional communication with the cloud, that are in charge for getting the deployment configuration, that are in charge for fetching the Docker images, for example, from the Docker repository, and kind of making sure that they are fetched and communicated on the secured way, and that they are always running according to the policies that we specified in the deployment configuration. Also, these two containers are in charge, or actually one of these two containers is in charge for communication between one module to another module. So actually, yeah, and this is one way how you can actually orchestrate, or how you can determine how your modules or workloads that are deployed on the IoT Edge, how they can communicate between each other. Now, on the other side of this story, what we will cover today is as well how you can also leverage Hive MQ as the MQTT broker to is kind of the communication point, not only between your machines that are sitting, let's say, outside of the Edge gateway as the device, but also is kind of the central communication point and internal communication point between the different workloads that are deployed on Azure IoT Edge. So yeah, in this case, so what Azure IoT Edge runtime, now actually once we introduced what means IoT Edge runtime, we can say that Azure IoT Edge runtime enables custom and cloud logic on IoT Edge devices, which we call modules. And these modules are actually nothing else but the Docker compatible containers that can run, for example, some of the Azure services, third-party services, for example, like in this case, HiveMQ, or your own custom code. So actually you can write your own custom module and have your custom logic for actually potentially, I don't know, data processing, pre-processing, analysis, and whatsoever. Yeah, so modules are deployed to IoT Edge devices, and they execute locally, of course, on these devices. Yeah. Next one. So IoT Edge module, it's yeah, kind of the unit of execution that is implemented as a Docker container or a Docker compatible container that actually runs your business logic on the IoT Edge. Each instance of this module, or each instance that is running on Azure IoT Edge, is orchestrated and deployed from IoT Hub. This is actually also one part of the story that we told when we mentioned cloud managed deployments. So that means that this approach actually enables sending, for example, commands or sending different configurations and settings to individual modules from the cloud. This is also, again, part of the what it means cloud managed and cloud orchestrated. And of course, what in order to actually facilitate some of these features, you can use the SDK to leverage these IoT Edge features, but actually this is not the requirement. You can also run just a plain, for example, in this situation we have deployed a Hive MQ broker that does not facilitate any of the IoT Edge SDKs, but it's still functional. But for example, if you want to use IoT Edge to communicate from one module or to send message from one module to another one, then it's recommended that you actually leverage the IoT Edge SDK or the module client SDK for enabling the communication and sending one message from one module or from one container to another one. And this is actually in some of the cases when you have the data processing that is kind of splitted in a couple of different stages. This is one of the convenient ways actually how to deal with and how to face this problem. Okay, next one. Yes, so like I've said, module-to-module communication on IoT Edge, or when I say module to module, very often I also mean, or we can kind of consider it as container to container communication, can be done via routing. And this is the core feature actually of IoT Edge here when it comes to the module to module communication. But not only to module communication, we also use the routing capabilities to actually determine which modules will send messages to the cloud. Because, for example, if you have 5 or 6 different modules, not every of them needs to send the telemetry to cloud, right? Because if you have some kind of the pipeline that deals with, I don't know, getting the data from the sensors, then you are doing some kind of pre-processing, then you are, I don't know, sending this information to a machine learning model deployed, and then the result you may want to send to the cloud. And obviously, as the then you can actually say through the routes that only from the last module that is kind of in this pipeline, only the messages that are output of this last module, only those messages sent to IoT Hub. And yeah, so this is actually the I would say the ways, or these are the ways how you can facilitate the IoT Edge and leverage IoT Edge features to enable container to container communication and also container to cloud communication once you determine or once your business logic actually determines which results and which conclusions from the devices, machines, or factory floor, shop floor you will send to cloud for further processing. Next one. And another concept actually that is here very important, like I've said, from the cloud we can actually send the commands, but we can also send the configurations to the individual modules or to the device or to the gateway itself. One of these features actually is very important when it comes to the device management, which actually this slide illustrates how firmware update potentially can be done through and how it can be managed from cloud. Where we actually, over here, we see that from the cloud as the first step, we actually initiate the firmware update by using the plain method code. And obviously on the device side or on the IoT Edge side, we can have the firmware update handler application or that actually receives the URL of the image of the firmware image that has to be replaced locally on the device. Now, on this flow, what it happens, or actually these kind of configurations that every device or every module has, we can actually split into the two main categories. One of them is actually changeable from the device, and or another one actually could be modified from the cloud. These properties or these parts of the settings very often, or in the terminology and in the Azure documentation, are called desired and reported properties. Desired properties are something actually that are desired from the cloud, and reported properties is what is the actual state and what is the actual status on the device itself. So obviously, when we initiate such a update from the cloud, we can actually do it by changing the desired property, and the device handler that is, let's say, implemented and deployed on the edge, for example, or on the normal device, can actually detect that the properties that this device has at the moment are not aligned with the desired properties. So actually it can then start the firmware update procedure by downloading first the image, replacing the initial image, then actually restarting the device itself, and on the next boot actually it can run the latest, for example, firmware, and report by changing the reported properties that actually now this particular device has the latest version of the firmware. So this is actually how this can work as well, and why this is also an important part and bit when we mentioned cloud orchestrated and cloud managed deployments, and also cloud managed device management. Okay, next one. Yeah, so, and now kind of before we go into the concrete problem, maybe just one of the difference or the summary and reflection on IoT in the cloud and IoT on the edge. So cloud solutions, I would say, very often they offer the big picture of the whole process, the big picture or the overview of all devices and machines. But very often that is not sufficient, right, for the devices and the machines, because these machines may have latency requirements, where latency actually plays a big role in order to have the reactions on the machines and on the shop floor, maybe to stop some processes before it causes further damages or additional costs. And of course, this very often needs to be done offline. So therefore, before the message reaches the cloud, we can actually leverage Edge, for example, either when if you are talking about concrete machine-to-machine communication that are not provisioned in the cloud, we can actually leverage Edge for example, protocol translation, identity translation, or for data normalizations, and in the case that we will cover in next couple of slides, machine-to-machine communication. And this is all about actually enabling reacting on time or facilitating and communication from one machine to another machine that is actually not concerned by the cloud. So like I've said, because the cloud in some cases it offers some of the it offers the view on the whole process, overview of all devices, machines, and maybe some third-party business integrations, and all of these kind of sensor level details or communication between devices or machines in some cases are not concerned or are not concerning cloud, because cloud actually maybe it's just interested on the results or only in the important bits of this communication. And this is actually why another reason, or kind of just to summarize why we need IoT as well on the edge. Next one. And this is actually the example which pretty much explains and covers all of the topics and the concepts Christoph and me introduced before. So I will quickly explain the architecture. So over here on all the way on, if you kind of go all the way from the left side to the right side, we have the publisher and the subscriber machine that are talking to each other through the Hive MQ broker. So subscriber machine is interested in the certain topic. It's listening for the certain types of news that, for example, publisher machines publish. And this is all, for example, that subscriber machine can react, potentially that it can switch off certain, I don't know, conveyor belt or something like that. Once the certain type of message, for example, failure type of message is detected from the publisher machine. On the other side, we can see that actually Hive MQ broker is deployed on IoT Edge device. And also over there, we can see that besides the IoT Edge runtime, which is the core part of IoT Edge, we have the subscriber module. And in this case, actually, subscriber module subscribes to one of the topics of Hive MQ broker, MQTT broker. And we can say that subscriber module in this case can be interested also whether in the same topic as subscriber machine, or maybe different topic or different topics. in order actually to process these messages to and maybe provide some additional custom logic before it's actually sent through the IoT Edge runtime all the way to Azure. Okay, next one. So what it takes, maybe here it's not visible enough, but actually HiveMQ module, it's in the red color. So what it takes to deploy HiveMQ broker from the cloud. So all of these deployments from the cloud actually are just the matter of the one plain configuration file. So it's not any kind of rocket science. You just actually specify what kind of containers you would like to run, what are their create options, how to you kind of instruct IoT Edge how it will run these containers once IoT Edge downloads these Docker images. So you specify which parameters to fetch, and of course you specify in this deployment configuration file, you specify from where these images can be fetched. And the next slide actually illustrates how does this deployment manifest looks like for the HiveMQ module, where we actually see in the settings section of this, it's a plain JSON, as you can see, and you can see actually that you instruct IoT Edge and you tell him, hey, get this HiveMQ module from the public Docker repository and use these create options to start it, where we actually bind 8080 protocol, port for actually using the web interface to actually check the status of the HiveMQ broker, and where we actually bind the MQTT port. Further down, you can actually see that we say that the restart policy, for example, is set to always, which means that in case that from whatever reason, in case that this container fails, restart it and make sure that it always runs. While, for example, in some cases, depending on your business logic, you may have different types of requirements and containers, for example, that just run one time. Okay, next one. Okay, let's now see what it takes to have the subscriber module. And actually for subscriber module, in this case, we used, next slide. For subscriber module, actually we used HiveMQ Java client library. But before we actually come to that point, this is actually just the deployment manifest that explains how custom module as well will be deployed. And as you can notice here, my custom module, obviously it's not the part of the public Docker repository, it's the part most probably of my private repository because I want to hide my IP. And here in the environment variables, I actually specify where and how this can be fetched and what are the credentials. So here in the settings section, actually image is specified or image location is fetched from the environment variable. In the create options, I actually just kind of set the host names, and this is just to kind of avoid the confusion to my publisher and subscriber modules, so that they don't have to use the plain IP addresses. They can actually use the host name to communicate with my HiveMQ broker deployed on IoT Edge. Next one. And how actually this communication between a subscriber module and HiveMQ on IoT Edge is done. We will see the code snippet on the next slide, which actually is using the HiveMQ client library, Java based and implemented actually in Java, where we actually subscribe to the certain topic that is specified as well somewhere in the environment variables. So any message that is actually received on this topic will actually trigger my module, will trigger the method in my module where I can actually process it, do something with it. I think in this case, I just print it to the output, but of course, since we are talking about the Java application, you can have all kind of different options and have your custom code that will actually process this message before it reaches the cloud. Next one. And the last is actually how, once our subscriber module receives the message from a HiveMQ broker, we want to push this message towards cloud. How this is done? This is done through the routing feature that is, I think, showed on the next slide. This is done actually through the routing feature, but since in this case our custom module actually leveraged the SDK, module client SDK, where we actually say that for every message that is received from the broker, we actually pack it and just send it to the outputs, to the output of the module. So actually every module has just input and output, and what happens with these inputs and these outputs you specify as well in your deployment manifest or deployment configuration file, where you can find the root section. And in the root section, you specify, hey, output of this module goes as an input of that module, or output of this module goes to upstream, and upstream actually is the code name for IoT Hub, or the code name for send messages to the cloud or send the messages to IoT Hub. Here you can also find how the route looks like for this concrete example, where we have the telemetry. I named the route telemetry subscriber module to IoT Hub, where we say, okay, output of subscriber module sent to upstream. All of this you can actually find in the documentation, and this syntax is pretty much simple. And for example, if I would have another module, and that would actually take the same message as an input, just this over here in the root, where I say outputs, I would actually replace with the input. And this is, or actually more or less, and this is the only difference in this case. So setting these routes, actually, it's really simple. Just it's kind of the matter to use the documentation in the proper way. And what is most important is your responsibility as developer is just to propagate the message to the right output, or handle the message from the right input, and how and when message actually reach the other module, IoT Edge Runtime takes over this responsibility for you. Next one. Yeah, and as you can see in this example, we leverage the IoT Edge to implement the machine-to-machine communication, but also to have some kind of the custom module that would actually consume some of the messages from the dedicated topic from the HiveMQ broker. And why this is actually very convenient? This is very convenient, as I think Christoph said. In some cases, Azure IoT, or actually Azure IoT Edge and Azure IoT Hub, do not leverage or did not implement, I would say, the full MQTT standard. So in these kind of cases also, it's very convenient to have, and the reason why to have such a broker deployed on the IoT Edge. For example, one example could be last will feature of MQTT, where you can actually determine whether one machine got disconnected in order to trigger some alarms through the cloud. So the way how you can implement this is actually you would specify the last will message, and you can actually subscribe and have the module that actually detects and subscribes to this topic. And once the broker actually publishes this message to that dedicated topic, you can actually use that module to propagate the message to the output, which at the end of the day, or at the end of the process, actually ends up in IoT Hub, where you can use this message to trigger some of the alarms and send messages saying, hey, this machine suddenly got off, for example. And of course, just kind of to summarize, the full code can be found on the GitHub, which actually demonstrates how does this example work end to end, all the way from publisher and subscribed machines and to as well IoT Edge deployment itself. Next one.
Okay. Thanks, Krasimir. I just wanted to give you a short, we're almost at the end, and I just wanted to give you a short outlook. What else could be done with the combination or with combining HiveMQ and IoT Edge. As we already talked about, one of the next things that that one could have a deeper look at is doing machine learning or AI at the edge and then at the cloud. You can pre-analyze it. You can utilize the existing Azure AI technologies, which are pretty awesome. And what you also can do is you can even integrate HiveMQ deeper into Azure IoT Edge by putting together HiveMQ extensions that allow you to extend HiveMQ with custom logic and let them use SDKs in there. We do have, or Krasimir and I did a prototype together doing that. So you can even interact more with IoT Edge than just shown. You can also look for more high availability at the edge, which means you can deploy HiveMQ in clusters, in high availability, fault-tolerant clusters. And you could also deploy more than one edge device if you need redundancy or stuff like that. And one thing that doesn't quite fit the theme, but is also possible, there's also a cloud version of HiveMQ, which is a managed HiveMQ in the cloud on demand. And that also is able to, or will be able to, talk to Azure Cloud in the future. Okay.
So I think there are 3 open questions right now, and you can ask your questions now to Christoph and Krasimir if there are questions. Otherwise, I'm just starting the poll, and we would be very happy if you take your time and give feedback. I don't know. Do you see the questions, Christoph and Krasimir?
Yes, I'm actually answering on the question that is related. So should I answer like this or continue typing?
You can just answer it in the video. So
okay. So the question was, does Azure Edge runs multiple individual image instances? If yes, do you perform testing in lab for individual image integration with other images? So if I understood this question well, actually you can run different or individual image instances on IoT Edge. So actually IoT Edge supports up to 20, I'm not sure if they increased that number, but up to 20 different images. Potentially this number could be extended in the near future. I'm not 100% sure. But this is based on the documentation, this information. And actually what you can do with IoT Edge as well, you can have the development environment. The most simpler way is actually to use, for example, Visual Studio Code and have the IoT Edge extension there and install the development extension for IoT Edge. And actually you can test it and develop it locally before you deploy it to the concrete device. The next one related for IoT Edge is, do Azure Image includes third-party solution as well? Actually, Hive MQ in this case is the third-party solution that we easily deployed to Azure IoT Edge, which means that the Docker image that you can have, you can easily deploy it through IoT Hub to IoT Edge in Azure IoT Edge enabled device. And I think this is all.
So then there are 2 questions for you, Christoph. I don't know if you can see it right now.
Yes. So the first question is, when HiveMQ support stops for version 3.1.1? I think this is a follow-up question to if HiveMQ does support MQTT 3 and MQTT 5. HiveMQ supports both of them, even at the same time. Clients can be mixed. Some can have MQTT, some can have MQTT 5. And there are currently no plans to stop support for HiveMQ 3, as there are a lot of devices in the field at our customers, for example, that are using MQTT 3 and that are not so easy to update, or even some of them aren't able to update to MQTT 5. So we will support MQTT 3 for at least a few years from now on, maybe 5, maybe 10. I can tell that right now, but it will be a few years, of course, for sure. The other question was, how much data can we pass in MQTT as payload in MQTT 5? The same amount as in MQTT 3, which is a maximum of 256 megabyte, I think. 256 megabyte. One has to be cautious because the amount of user properties you put in the packet, the whole MQTT packet, including user properties, topic, and other fields, can be 256 megabytes large. So if you don't have any user properties, you currently can put a lot of megabytes in there. Is it possible to publish data from one device to multiple topics? With MQTT, it is not possible, but with the HiveMQ extension system, you can actually do that. But you would have to build an extension for HiveMQ for it, which is pretty simple. It's just a Java SDK and probably would require only a few lines of code.
All right. So I think there are no, okay. So I think we're just answering this one last question because we are slightly over time. Or do you want to follow up on this one, Christoph?
I think we'll follow up.
Okay.
I don't know which way to focus
So we will follow up on this question, but so thank you for watching the webinar and thank you both for your presentation. We hope you enjoyed the webinar. So if you want to watch the webinar again, we will make the video available on our YouTube channel. So I sent you the link in the chat. All unanswered questions will also be available on the community forum, and we will follow up with the person himself. Then there's also the full GitHub code on, like, in the chat, and you can also subscribe to our newsletter, which is also which I also sent you a link in the chat. So yeah, you will stay updated on our upcoming webinars, and I think that's it. And thanks for joining us today. I hope you liked it, and thank you for your presentation. So goodbye. Have a nice week.
Thanks, everyone. Bye-bye.
Thanks for watching. Bye.